Okay, so this lesson today is just a wee bit of consolidation from what we were been doing yesterday, and we are going to try and look at a different way some of the questions you might be asked, how we'll do them as well. Okay, so it's just 2 wee questions, and then you've got some questions to work through, and as always, you can ask your teacher for help if you get stuck. So, we've got a wee example here, and it's saying we've got 0.16 grams of methanol, it's burned in a spirit burner. The heat from this combustion causes the temperature of 0.1 kilograms of water to be raised from 20 degrees to 27 degrees. Use this information to calculate the enthalpy of combustion of methanol. Okay, so this is exactly the same as what we've been doing the previous day. We're going to first have to work out the energy change, and then use this to work out the enthalpy, and that's the energy change for 1 mole. So, let's get started. The equation we're going to need to start us off is going to be E equals Cm delta T. The C is always 4.18, and it does say we're using water as well, so that's going to be 4.18. Times the mass, it does mention 0.1 kilograms of water. Don't use the 0.16 grams of methanol, you use that in the next part. So 0.1, and the temperature change, it says it goes from 20 degrees Celsius to 27 degrees Celsius. That is going to be a temperature increase of 7 degrees. So the answer for this in the calculator is going to be 2.926 kilojoules. Obviously, because the energy has been released from the reaction is losing heat. So it's going to be a negative there because it's exothermic. And that is the answer to the first part. We need to turn this into an enthalpy, and to be able to do this, we're obviously going to have to use the proportion like we were doing in the previous lesson. So let's do that here. We know that from the question, 0.16 grams of methanol is going to give us minus 2.926 kilojoules. What we're going to have to do is we're going to have to work out 1 mole. And to do that, we need to understand we're using methanol, and we've got the chemical formula for methanol here. What we're going to do is we're going to work out its GFM to work out the mass of 1 mole, and then we're going to use a proportion to work out the enthalpy change for this reaction. So I'm going to do my GFM up here, so it was CH3OH. That means we've got 1 carbon, which is 12 grams. We've got 3 hydrogens, which are each 1 gram. We've got 1 oxygen, which is 16 grams. And we've got 1 hydrogen, which is 1 grams. So all adds up to 32 grams. So go back down to where we were working here, and we now know that 1 mole is 32 grams. So we need to use our proportion here. We have started with 0.16, and that has given us minus 2.926 kilojoules. We need to find out what 32 grams is going to give us. And remember we said that we did new over old times the other side. Or, if you wanted to use a cross multiplication, you can use that as well, and I'll show you how to do that at the end. So do 32 grams divided by 0.16, and we'll times that by the other side, which is going to be minus, we'll leave the minus out, we'll just put it back at the end, 2.926 kilojoules. That works out to be, when we simplify this wee thing here, if you just did that in the calculator on its own, just sometimes it can get confusing. It's easier to do this to make sure your calculation is going to be correct. Sometimes if you do it in the calculator and it's maybe an older calculator, it doesn't give you the answer you would expect because it's not doing it in the order that you think it's working in. So do 200, because that's the answer for this, times by 2.926, and that comes out to be 585.2 kilojoules, and because this is an enthalpy now, that's per mole, and remember we're negative here as well because it's exothermic. What I will quickly do as well is I'll show you how to do that by the cross multiplication. So we'd got 0.16 divided by 32 is the same as 2.926 divided by x. So if you rearrange that, you get x to be 2.926 times 32 divided by 0.16. And that comes out to be the exact same answer, it's just a different way of doing it. There you go. And that is as we have worked out the enthalpy change for that, for methanol. We're going to try a different one now. This is going to be slightly easier, just the way it's asking. We've got one less step to work out. We don't actually have to work out a GFM, but it's going to be the exact same method that we'll be following to do this. Okay, so it says 0.02 moles, not grams of an alcohol. It doesn't matter which alcohol it is because you know what number of moles it is. That's going to be burned in a spirit burner. It says the heat given out is used to raise the temperature of 0.4 kilograms of water by 10 degrees Celsius, and we're going to have to calculate the enthalpy of combustion of this alcohol. Now, this is easy enough. It's just the same as what we've been doing, and we know that we start off with our favourite equation, which is E equals Cm delta T. We know by now that the C is definitely 4.18, and it does mention water, just as a wee check, so we're okay there. Our mass of water is 0.4, and our temperature change is 10 degrees C. That means that when we put this into the calculator, it gives us 16.72 kilojoules, and we know that this is also being burned in a spirit burner. The spirit burner is giving off the energy, so it's giving it out, which means that the chemical reaction itself of the combustion must be exothermic, so it's a negative. There we go, that's the first part of that done. Now we need to do the proportional part. However, because it's not mentioning mass and it doesn't mention which chemical you're using, we would use the moles, and the fact that it's got moles there makes that telling you what you're going to do. So instead of putting grams here, we'll just do number of moles. We know that 0.02 moles would give us minus 16.72 kilojoules. We now want to find this for 1 mole, and we can do that because we know that we've got the ratios in terms of moles. That may just be the same as using grams. You could have pretend for a minute that doesn't say 1 mole and 0.02 moles, it would say 1 gram and 0.02 grams. It would work the same way, but we're going to use moles for this. So again, new over old times the other side is going to be 1 divided by 0.02 times by 16.72, and that comes out to be on the calculator minus, sorry, I'll do this in the 2 steps I was doing. That would be 50 times by 16.72. That ends up being this, minus 836 kilojoules per mole. And remember, we're keeping that negative there because it is exothermic. I'm going to show you how to do that using the cross multiplication. As you can see, that's no different to what we've been doing so far. The only thing is it doesn't have grams, we're just using moles. And you don't have to work out a GFM. So cross multiplication then is going to be 0.02 divided by 1 is the same as minus 16.72 divided by x. So x is going to be 16.72 divided by 0.202. That answer is going to be the same, minus 836 kilojoules per mole. And make sure you're remembering the moles, because it's an enthalpy, which is the energy released based on 1 mole being combusted. Okay, so the next steps are, your teacher will have also uploaded a worksheet. It's got questions of these type. So there's about 4 or 5 questions of the first kind we looked at, just like this, where you would have to use, just like what we've been doing yesterday, nothing different, just more practice, where you have to work out the energy first and then use the mass to work out the enthalpy. But there are also a few of, and I've put that as a type B question, and it's just you're using moles, okay, or type 2 question and it's just moles, so you don't have to worry about masses. Okay, so if you get stuck, as always, you know you can ask your teacher. Good luck.